Let's talk about the second derivative. Well, first we know that the first derivative, f prime of x, is the instantaneous rate of change of f of x. F double prime is the instantaneous rate of change of the first derivative. There's a significance to f double prime. So let's use this example here. We've graphed f of x, f prime, and now f double prime. And an interesting way of looking at this is viewing this as f is the position function of an object away from the starting line. F prime is the velocity of the object, and f double prime then would be the acceleration in this interpretation. Okay, so first let's talk about the relationship here between f prime and f. So f is increasing so that the derivatives are positive, and then they're less positive coming down here, and that's why the slopes are dropping until you get to this point here, which corresponds to this point where the slopes is 0 there. So the object has come away from the starting line and then decided to return back, and so it came to a stop right here, corresponding to velocity equaling 0. Now on this side the function is decreasing, and that's why the f prime curve is negative down here until you get to here. This corresponds to this point right here where the slope is 0, which means the derivative was 0. Now the slopes are positive over on this side, more positive and more positive, more steep, which is why the derivative is increasing. It's positive and it's getting higher and higher values. Now let's talk about the relationship between f prime and f double prime. So as these velocities were decreasing, going down, that meant that its rate of change was negative. That's why these f double prime values are all negative, because the f prime keeps on decreasing, keeps on decreasing, keeps on decreasing until you get to here. So f double prime was all negative here until this point, which corresponds to this point. There, f prime had a level point, slope 0, which means that its derivative, which is f double prime, had a 0 point there. Then the f prime curve started increasing. Velocity started picking up, so it was accelerating. That's why the f double prime values are positive. Now let's talk about the relationship between the f graph and the f double prime. Alright, so here f was increasing. Slopes were very positive, but they were dropping. The slopes were dropping, decreasing. That's why the f prime double prime curve down here was negative. Another way of looking at that is that since these slopes were dropping the entire way to this point here, it's concave down. concave down. And the F double prime is negative there when it's concave down. So these two ideas match up. F double prime negative means that the original curve is concave down. Then you have a turning point of the F prime, which means that all of a sudden the original graph was decreasing, but it's decreasing by less and less, creating a concave up look to it, corresponding to F double prime being greater than 0. So since F double prime is greater than 0, that means the rate of change of F prime was positive. That means that the slopes on the velocity curve are getting steeper. So here you have your concave up, corresponding to your F double prime being greater than 0. And then there's only one more point we haven't talked about, and that's what happens when F double prime is 0 by way of changing from being negative to positive right here at this point. Well, we had an inflection point right here. That is an inflection because the curve stopped being concave down and started being concave up. So that will happen when the F double prime curve changes signs from negative to positive, and it'll go through 0, and that's when you have an inflection point. There's times where an F double prime could equal 0, and you don't have an inflection point. It's possible that F double prime can equal 0 and yet no inflection. And that will happen when F double prime doesn't cross 0. I mean, doesn't change sign across 0. If it just maintains. So if the F double prime curve touches a point, is 0, but then comes back down, you will not have an inflection point there. So when you're looking for inflection points, you're definitely looking for a place where F double prime is 0, but that the sign changes from negative to positive or positive to negative.